You're listening to Ddrn podcast, produced by Danish Development Research Network in Copenhagen, Denmark.
Next part of the workshop is a presentation by Dylan, who is, at least seen in my perspective, our drone expert at SDU, because he's the one I know best from the drone group. But we have a rather vast drone development group, but Dylan can tell you more about that. Dylan and I have been working together on publications and are now also trying to develop a project application for a resource monitoring project in South Africa. But maybe you should tell a little more about who you are, Dylan, and what you do with drones. I've been to your office. You get a really wide perspective of what drones can look like when you go to Dylan's office. I will have to mention.
Yeah, I'm on holiday right now, so I'm in the U.S. But yeah, normally you would see just a huge family of drones behind me, representing years of research. So yeah, maybe I have a few slides that hopefully will show a little bit of what I'm working on. So yeah, thanks for the introduction. Yeah, it's really great to be here, and I mean, this is such an important topic. I'm glad that there's some students out there that are interested in it and that are taking the time to be part of this discussion. And I'm hoping also that there will be some that follow up and listen to this later on, because it is really a fascinating area to develop in, and also, I mean, I think there's no other place where there's bigger opportunities and perhaps also bigger risks than there is collaborating and trying to work in developing economies. And I think David really pointed out some of the challenges and nuances of what goes into this kind of work. So I'm hoping that I can unfold a little bit of that in my talk as well. So the title of my talk is Ethics and Design of Healthcare and Humanitarian Drones. I'm actually going to use a case study in Denmark as sort of the point of departure, because this is one of the areas where I've worked the most over the last couple of years. But I think what you'll see is that the approach that I'm using, which is called value-sensitive design, where you use ethics to actively engage with human values in the technological development process, I think what you'll see is that process works very well in a lot of different contexts. So it works fine in Denmark, and it works quite well in developing economies as well. And yeah, so hopefully that's okay. First, I'll start with this Danish drone example, and then I will introduce you to a project that's just starting in Sierra Leone in a collaboration with Engineers Without Borders Denmark and partners in West Africa. So yes, I'm an associate professor at the Ddrn Center at SDU, and as Morten mentioned, there's quite a few of us. I think there's almost 20 researchers and teachers working there at the center now. And yeah, my sort of niche is that I'm a mechanical engineer and aerospace engineer. And so my background is about, sort of the mechanical aspects of things that fly. And over the last several years, my career and my research direction is sort of, I would say, broadened out and become more holistic. And because I kind of was searching for, okay, what is the point of what is the point of this stuff that I'm doing? Is engineering really going to make the world a better place? And early in my career, I was thoroughly convinced that if I just made jets and made high-tech stuff, that would sort of move society forward. So that was kind of the level of analysis. Technology is good, technology moves us forward, therefore I make technology and I help the world become a little bit better. As I got older, I would say I got maybe a slightly more skeptical of this approach, or maybe I felt like there needed to be some nuance to it. And so during my PhD, I really got to explore this topic. And what I did was I used this value-sensitive design approach and tried to figure out how do you actively incorporate human values into the design process of drones. And drones are sort of my area of expertise now. And yeah, in combination with sort of like ethically informed design choices. And again, this is just, I think in some ways I was just sort of in the right place at the right time, because drones are, they're an upcoming technology and they offer a ton of promise. And I think that they also represent quite a lot of risks in different areas. So if you want to think about technology development and a very interesting case study for how can that go right and how can that go wrong, or how complex is it, the drones are a really good case study. So hopefully I can demonstrate that in the next few minutes. let's see if my slides will respond to going to the next. Yeah, so this is about me. As I already introduced myself, I think you can kind of get the main idea. But I guess now I see myself sort of as maybe even as an activist engineer. So I see how important that the design of technology is and the impact that it has on society, and how much responsibility we have as engineers and scientists and researchers in making some kind of positive impact in society. So what I'm trying to do is use design and prototypes and holistic design processes, engagement with all kinds of different stakeholders in order to try and make what I consider to be more just technologies. And I have some discussion questions in here, as David did as well. I'm not sure how many people are around that can engage in it, but so maybe we'll just save them to the end. But yeah, these are just some things that I wanted to bring up. You know, what is the connection with ethics and technology? What is the connection with global sustainable production and ethics? Yeah, so basically the way I see all of these things is that they are a sort of technology, or we're trying to make some kind of intervention in society, whether it's a change in the production process or whether it's a drone changing the way that people do their work. And so therefore we need to be quite cognizant of what kind of changes will come from the things that we're intervening with the technology, with the change in production, these kind of things. So hopefully we can discuss that a bit towards the end. Yeah, so my research has been zooming out over the last several years. It was highly focused, so I did a lot of work with composite materials. Yeah, I did a lot of work with manufacturing aircraft in an efficient way. I actually used lean manufacturing at Boeing to help develop aircraft that were produced in a more efficient way. And then, yeah, these last several years especially has been zooming out and out and out. And that means that I've ended up reading a fair amount of philosophy of technology. And one of the big things that we sort of need to get around is that when we talk about technology, it's actually has quite a lot of moral implications. So this old idea that we can just make technology and however it's used is up to the user is quite an outdated concept in the philosophy of technology. So basically what that means is that when you make stuff, that stuff gives you the ability to do things, sometimes good things, sometimes bad things. And we need to be aware of that in the design process and actively engage in that. Yeah, and this is just a little bit of information about the Ddrn Center that I'm a part of. And myself and a couple of other colleagues are quite engaged in, I would say, trying to use technology to make the world better. And so we've influenced the definition of what it is that we're supposed to do there at the center in our mission statement. So what we say currently is that we make drones and we do research and innovation and collaborate in order to benefit society. And I think this is notable because if you have a research group that says, well, we want to make the best technology, for example, we want to make the most efficient drone swarm or the most efficient AI algorithm. That's a different task than trying to make technology that benefits society. And so when you have a mission statement like this, it means that you need to be actively engaged in making good technology, but also technology that then links in with society in a positive way. So this means that we need to have very close collaborations with social scientists doing empirical work, and we need to have very good connections with humanists as well, because yeah, a lot of these issues have philosophical implications. And so that's sort of what I've been doing over the last several years, is trying to build up these capacities and trying to shift the thinking in the research group from being purely about how do we make stuff work to how do we make good stuff work. Yeah, so recently the University of Southern Denmark has become an SDG university. And so that means that the SDGs are supposed to be baked into everything that we do. So from as far as research is concerned, education, collaboration, and also, you know, like do we waste food when we have meetings? Do we drive too many gasoline-powered vehicles and this kind of stuff? But yeah, one thing that I did want to discuss though at the end is just what about this framework of the SDGs? What are some strengths and weaknesses of it? Personally, I can see a lot of benefits to it. I think most of us here in this panel believe that sustainable development. Sustainability is an amazing thing, and having this high level of focus on it is an extremely positive thing. That being said, there are also some of the SDGs that are, I would say, probably clearly politically motivated. So things like, how do we make economic growth and still be sustainable? Some of these concepts can be sometimes a bit contradictory. And also sometimes if you focus too narrowly on optimizing one of the SDGs, you can have problems with the other ones. So yeah, taking a holistic approach, as David suggested, I think is quite useful. But at any rate, I think it's a useful tool and can definitely get us started in the discussion. Yeah, so let's see, what do I have the title of this slide being here? I think this is just an introduction to drones used for healthcare purposes. So in 2019, I went to Rwanda. I was in Kigali, in the capital city, and there was a drone conference going on there. And here in the GIF, you can see that's the company Zipline, and they're actually the most used, the most highly operated drone in the world, operating in Rwanda mostly. And they're using these drones to drop blood bags. So they have sort of the central hub you can see here on the right side that I'm standing in front of, which has a bunch of blood products. And then if they find out, oh, someone is just given birth and they're hemorrhaging and they're losing blood rapidly, let's ship a liter or however much to this rural area using the drone. So the drone flies out autonomously, and then it drops this parachute with a blood supply inside of it. And one thing that they often do is in healthcare, people will refer to this as drones for good. So they have this hashtag on social media, hashtag drones for good. And yeah, I think that's quite a compelling statement, but also it's usually more complex than that. So, when you introduce a drone like this into a complex healthcare system in a country like Rwanda, I would argue it's not always just good things that come from it. It's complex, and certain people benefit and certain people maybe even are harmed. So those people that were, for example, delivering the blood products before, maybe they're harmed, and maybe people that are working in technology fields are benefiting quite a bit because they're now developing drones and selling them and maintaining this kind of stuff. Yeah, I don't want to go into a huge lecture on drones, but there are a bunch of different types that you can see here. Maybe people are a bit familiar with them. So yeah, maybe there's like these helicopter types, and then ones that are like small airplanes. And then on the right-hand side, you have some that are sort of hybrids between these two. And the reason that we use drones is usually to carry stuff. Typically it's to carry sensors of some kind, or to carry cargo. So those are the biggest uses. And also in the future, it might be actually transportation of people. So it could be basically flying cars that are flying autonomously. Yeah, the point I wanted to make here was kind of tied in with the one that was made earlier, which is that technology is not ethically neutral. So now we're making stuff that's going to have a big impact in society. And in the US, we always have this debate about guns killing people, or is it people killing people? Like who has the responsibility? Is it the technology, the gun, or is it the human actor? And I would say that from a philosophy of technology standpoint, well, they both have some agency. So the user has some kind of responsibility, and then also the designer and the technology's capabilities itself also play a part. So if you have a drone that can't fly very far, then the risks of that drone being used to do stuff that requires flying very far or carrying very heavy stuff doesn't exist anymore. So what I would suggest is that we just need to be very active in managing the capabilities of the technology to fit in the context of use. Yeah, we also have this issue of dual use, particularly in drones, because it's just a very flexible technology that can be used for both good and bad things from a moral standpoint, and also for military and non-military activities. And yeah, I mean, there's a pretty gray area as well when it comes to things like surveillance, border security, and this kind of thing. So yeah, again, if you want to be part of a certain industry, then you need to be aware that there's quite a lot of flexibility of the stuff that you make being used in different ways. So these are some of the challenges that we're faced with, and then what do we do about it? And as I mentioned earlier, one of the tools that I really like to use is this one called value sensitive design. And one of the key elements of it is that it's holistic and that it's interdisciplinary. And so I would say that that makes it extremely challenging to work with, but also very engaging and exciting, because you sort of get the overview and you get to see the whole picture. And what you'll find is that as you change the specifications of the technology, or as you learn more about how humans and technology are interacting, all of these elements will interact and change. So the typical model that we use is where we have this sort of conceptual analysis, an empirical phase, and then a technological phase. And so the conceptual phase, I think, is what kind of sets value sensitive design apart from some other kind of design approaches. And this is about the philosophical and ethical aspects of the project. It also includes, oops, wrong button. It also includes a lot of engagement with stakeholders, as David mentioned. It's not just a matter of who's the most powerful person, who's the one with the money. It's a matter of who are the people that are directly impacted. So I mean, the factory workers are directly impacted. People that drones are flying over are directly impacted. Engaging with them, engaging with labor unions, and all of these kind of things. So I would say in that way, it's a different approach than a more typical business-oriented one, where you just look at the person with the money and the power. The empirical phase is quite important. So sometimes you have a great idea that seems like it'll work out just wonderfully, and you're going to make this new technology and it's going to change the world and fix all kinds of problems. And then you find out in practice, the people don't interact with the technology in the way that you expected. So one example that comes to mind is these electric scooters that we're now seeing all over the city in Denmark, and probably all over the world. And I mean, some early analysis showed that they could be quite sustainable. So, it would sort of fill this last mile. If you want to do a commute on public transport, and then you can take this electric scooter, and it will, could be a more sustainable form of transportation. So I think it sounded pretty good on paper. And then we see in practice, people are throwing them into the river, and young kids are riding with two people on them, and they're drunk and they're crashing into different stuff, and they're blocking the road for people that have disabilities. So I mean, this empirical phase is very important because it's sort of a feedback loop of, okay, well, this is what we thought would happen, but what actually happens in practice. And this empirical phase is often undertaken by social scientists. So we have, I've done a little bit of social science myself, and David mentioned one, which is action research, which I was actually the subject of some action research process, which was pretty fun. But yeah, and I've done some focus groups and some other things like that. But in general, I tend to collaborate with my colleagues that actually know what they're doing. And yeah, so we do things like ask people, what do they think about drone technology, and what are the concerns, what are their hopes and dreams about them, and then as an engineer, I look at that as fantastic data that I can then go and try to incorporate into my design. And if you're a technologist like I am, then you take these conceptual, philosophical aspects and stakeholder inputs. I take the empirical data, and then I make a prototype, and I try to incorporate those abstract and social inputs into the actual design of the technology. And then it sort of iterates in a loop, and yeah, the cycle continues, hopefully until we get it right. And for us engineers, sometimes we're not super familiar with human values and all these abstract things about feelings. So there's been a lot of work with sort of identifying some human values that are often relevant, and you'll see them here. So things like environmental sustainability, of course, things about trust and human autonomy. Do people have the ability to live their lives and not feel like they're being spied on with drones flying around them all the time? Do they have a trust in these systems? Are the systems made in a way that they're transparent in their operation? And these kind of things. Yeah, and to give a little bit more practical example, one of the tools that we use is this ethical framework And so this is one that myself and a colleague from TU Delft in the Netherlands developed for drones in public healthcare. So we can talk about very abstract things like, okay, the drone, the healthcare drone should be implemented in a fair way. It should, uphold human autonomy and agency. It shouldn't do any harm. It should do good, and it should be transparent in its operations. So those are quite abstract things. And then we sort of like boil those down to more specific things. So then we talk about human values of things like human welfare. Is the drone going to transport medical supplies faster, which means that if you live on an island, you can get the medical care that you need more rapidly. Well, what about the risks? I mean, now drones are flying over people. What if a drone falls down and hits someone or causes a car accident or even kills somebody? So yeah, as you can see, it's pretty complex. Yeah, there's a lot of interaction and reaction between all of these different elements. And basically, at the end of the day, we need to boil these down through the norms, which has a lot to do with the context. So is it in Myanmar? Is it in Denmark? Is it in the United States? We need to be very aware of what things like privacy mean to an American compared to what does a thing like privacy mean in Denmark. Danish citizens are often more trusting of the government than American citizens. So if you want to design a drone that's going to preserve people's privacy and going to operate in the United States, you need to be very aware of this. And then the aim is to take all these inputs and then boil them down into design requirements. So at the end of the day, the engineers can get on with the work that we're used to doing. Yeah, okay, so that's a lot of theoretical talk. At the end of the day, we make stuff, and this is an example of some of the stuff that I've developed. So this is a drone designed for transporting small medical samples from the island of Ærø at the south of Denmark into the city of Svendborg, where they have more advanced testing capabilities. Excuse me. And as you can see, it's in some ways, I guess it looks like a typical fixed-wing drone, and in other ways, it's maybe a bit different. One of the tools that we developed during my research was this concept called capability caution. And so what that means is specifying the technology so that it does what you want it to do and can't do a whole bunch of other stuff so that it can't be misused. And that includes things like considering the context of use. So when we're flying from Ærø, this is an island community that's known for calmness. If you were perhaps operating in New York City, people would be used to all the noise and clutter and stuff flying everywhere. So maybe that would be different. But here we're talking about a very calm community. So that, to me, that means I need to be very, very cognizant of the sound profile of the drone. I need to be very aware of the size of it and the flight path that it's going to take if it's going to be operating over people from this calm island. I also need to be very considerate a lot these aspects of privacy. I need to remember that when I automate a task, I am changing someone's work. So the person that used to drive these medical samples in a big cooler, drive them to the ferry terminal, wait for the ferry, go on the ferry, and then drive them into the test facility at Svendborg, their job is essentially going to change, right? So maybe it will be supplemented with a drone. That's the way that this particular drone is designed, is that it's only for very critical, very, extremely urgent medical supplies, not normal operations. So that means that it might be a supplement to the normal operation, but there are, of course, concepts where it could be completely replacing the transportation project, the transportation of the samples. And that means that person's job would change. Either they would have to become a drone pilot or they would have to find a different job. Yeah, we also need to consider things about safety, drones falling down, issues of security and even misuse. So imagine that there's the Queen is visiting the island of Ærø, which she does, I guess, on her sailing trip. Imagine she gets ill and they need to very urgently transport her blood sample by drone, and the drone falls down. Then we basically have an important person's DNA out there in the public. So issues of safety and security and misuse are very relevant. And I guess if you wanted to make a drone that was doing bad things, but no one would suspect anything of, you should probably make it look like a healthcare drone because people would probably trust it a little bit more. And the final principle, I think, is the most abstract, but maybe the most important one. And that is, okay, what's going to happen in the future? If we keep developing in this direction, if we keep making more drones, more autonomous, more capable, faster, stronger, better, where is that going to lead us? What is that? What are going to be the far-reaching implications to the workforce, to the environment, and these kind of things? Yeah. So how do you actually implement some of these things? One of the most important when it comes to drones, actually, I think it's maybe even the #1 concern over safety that people in the public have is this drone spying on me? Is this drone watching me and recording me? And currently, there's not a very good way to demonstrate from the drone that the thing is or is not containing a camera. So what we did in this drone is we made a privacy-preserving camera system. What it does is it just doesn't turn on until the drone is in the air. And that's quite useful because what we found was, you're getting the drone ready and you're there and you're standing around it and you're loading up the samples and you're talking with your, colleagues and your friends about, what they did in the weekend, and your face is up in the camera and all this. So all of your personal data, your biometric data is being captured, private details of your life, if you're sharing those, are being recorded. And essentially, according to GDPR, you shouldn't collect data that you don't need to collect. And essentially, you don't need that data. So we don't turn on the camera until the drone is actually flying. Then we wanted to have the drone be have a more manual operation, so that there would actually be a pilot driving it. And in order to do this, you need some kind of camera system or some kind of sensors to make sure you don't crash into anything. What we found was that we could actually reduce the resolution of the camera to be very, very low, like 144p at very low altitudes, and you can still navigate. You can still see, okay, well, that's the ground, that's the sky. I need to get away from the ground and go up to the sky. Then as you climb up and increase altitude, then the resolution of the camera increases. So when you're up at 75 or 80 meters, then the resolution is full HD, and you can look and see where you're going, and you can see if there's birds or people or whatever. But the camera then is far enough away that you cannot collect data on my face or people's license plates or things like this. So basically what we've tried to do is to make a system that preserves privacy by design. And so if you have people come and say, oh, I'm concerned about this drone, invading my privacy, you can say, well, this drone is incapable of capturing your private data if you're, because of its specifications. And I think that this is a better way to go than just saying, trust us, we won't do anything bad with your data. Another example with cargo drones is that you can, at least in theory, put anything you want on them. So that could be even nefarious things or bombs or who knows what. So we did some kind of low fidelity prototyping here of making, an RFID system, which is mounted onto the medical sample. And then the drone has a sensor inside, an RFID reader, which only weighs, the whole system weighs like 50 grams or something, quite light. And the system verifies that this is in fact the payload that you want inside. And even the shape of the payload bay is designed so you can just put the thing that you want to be able to put in there. And there's a transparent cover so you can see what's inside. And we were even discussing, since the drone will fly from a fixed position to another fixed position, hospital to hospital, you could even have some kind of scanning that takes place around the exterior of the drone to make sure that nothing has been attached to the outside of it. Yeah, and so so far this drone has been flown only out at the airport in Ddrn in northern part of Funan. So it hasn't been out there in the real world yet, but it's ready. It's ready when the time comes. So yeah, that is the Danish example, and I think now I can transition into the project that we're doing with Sierra Leone. So basically, this value-sensitive design process that I introduced, we're going to use a similar process for developing a drone to do mapping in Sierra Leone. So if you start out by thinking about what are the human values associated and what is the cultural context that we're working in, the situation in West Africa is that their land rights are not established from a legal basis. Basically, people have inherited land, so they own and occupy and use it. Many of them, especially the poor, are using it for farming, but there's no legal basis for their land rights. And what has happened in practice is that, in particular, foreign companies will lease land from the citizens, and they will do mining, for example, mining operations, and they will start encroaching and taking more and more of the people's land and extracting resources from it. And the citizens have no recourse because they cannot prove that that is, in fact, their land, the border of their land, or that the mining company is, taking more than they agreed to. And this is particularly a problem with the poor, and it's also particularly a problem with women, because women's land rights have not always been respected in the past. And so it's only very recently where there have been projects where they've tried to say, okay, female heads of households, their land rights still exist and they need to be respected. So what we want to do in this project is it's a collaboration between Engineers Without Borders Denmark, which I'm a volunteer at, and SDU, as well as an organization called Young Surveyors, and then also the Ministry of Lands in Sierra Leone, as well as the citizens of Sierra Leone. So that's the situation, and again, the context. Technology development is very contextual, and that matters a lot. So the drone that I developed for Denmark, that was for this very nice, lovely flat country that we have in Denmark. Very small and quite has good road infrastructure and has 4G and soon 5G connections. And then in contrast, we have Sierra Leone here, which is a very hilly, in some places very hilly, in some places very, very vast and flat lands. Huge country. I think it's 77,000 square kilometers, of which 0.001% have been mapped, and there's official documentation on it. So this is the context that we're working in. And from a technological standpoint, what we're thinking is we want to actually empower local people to be able to produce the drone and develop it in a way that supports their values. And so it's a tool that they can use to map their own country. And so what we're thinking is the cost of drones is very, very high in comparison to how much resources they have available. So what we're doing is we want to upcycle a lot of the components that we're going to use in the drone. So I have a master's student right now named Kenneth, and he has developed basically an app on an older Android smartphone, which allows the smartphone to be the flight controller of the drone. And so the smartphone reads, it has sensors inside that allows the drone to, allows the system to figure out what is the drone doing, is it pitching up or down, left or right? And also it allows you to create a map of the route that you want the drone to fly. And then this is outputted through the USB port into a microcontroller that then will actually control the actuators of the drone. We're also doing some investigations into using old laptop batteries. So actually the cells that you see in laptops, these are 18650 Lion cells. These are quite high energy density. The company that I showed you at the beginning, Zipline, is actually using these, a huge box filled with these for their drone. And we found that even older laptops, the cells still have a lot of life in them. So this would be a very good source of low cost lithium batteries. And we're also, I think we're in a bit of a problem to try and find out a good source of electric motors. We got some feedback from our stakeholders that, here we have an electric drill motor, and they said, well, if there's an electric drill motor around, we're using it as an electric drill. So we're going to need to find a better source for that. And you can see on the right-hand side, here's a very simple, I think I used 15 minutes to build this. Just a prototype concept of a very, very low cost drone that could be perhaps used for this task. It's made of bamboo sticks, which you can get there in Sierra Leone, a little bit of fabric. It's covered in some plastic film, and there's some cardboard for the flaps. So I mean, this is of course a very extreme version of how local and low cost you could go, and we need to weigh that against the capabilities that it has, and make sure that it's still going to be useful. But yeah, that's the idea. Is I'm very interested in seeing how extreme we can be in in localizing the manufacturing of this drone. Yeah, and as I mentioned earlier, it's a collaboration, Engineers Without Borders and SDU. Oh yeah, just speaking about those collaborations, this one is still new and I haven't gone to Sierra Leone yet, but I probably will in February. So far, my other work in, I would say, emerging economies has been with Engineers Without Borders and the African Mask Project. So I was the guy that was part of a small team that, and I designed this fabric mask. And yeah, we had partners in Engineers Without Borders that were in Sierra Leone and Guinea-Bissau. And we developed this mask to be made from local materials. You can see this one's made of a fabric that they can get at the market. And yeah, that was to help try and slow down the spread of COVID during the very beginning of the pandemic. And my experience in this project was, it was incredibly fulfilling. It was incredibly challenging. So I was sitting in my, in my apartment in Denmark, making training videos and trying to, understand what materials they have available and what skills they have available. There's quite a lot of tailors in Guinea-Bissau and Sierra Leone, and we had about 10 or 15 of them at each location. And so we had some Zoom chats, and I showed them the design, and they were like, can you change this? Can you change that? So we had a really fantastic dialogue back and forth. And then another thing that was really great was it actually went really fast. So I made this training video, and then, I mean, in a few weeks, they had produced a bunch of prototypes. And since the project started, they have produced almost 100,000 masks, around 50,000 in Sierra Leone and around 50,000 in Guinea-Bissau. And so this is going to be the largest clinical test of, or sorry, not clinical test, but largest sort of in situ test of fabric masks in the world. So that was a really, fulfilling thing to be a part of, to have these collaborations with people on, far away, and then, to very rapidly see the results of your work, being produced. Sometimes in academia, we sit and we write and we write and we hope that someone's reading it, and we don't always know if that's the case. But in this project, it went quickly and things happened. And so that's one thing I would say to the students out there is, if you want to see some results from what it is that you're doing and have a direct impact to people's lives, these kind of projects can definitely fulfill that role. Yeah, so that's the main part of my talk. The rest is just some kind of statements or notes or takeaways about sort of the holistic concept of technology and human values and innovation. This is a quote from a colleague that I really like, from a pedagogy conference a couple of years ago. And he says, technology without ethics allows us to do stupid things in a very clever way. And this is sort of one of my mantras. I mean, do we really need it? Is it really making things better? In my experience, there's some very good possibilities for the use of drones, but it's never straightforward. It's never just good for everybody equally. So yeah, are we just doing something dumb in a very clever way? Another thing I think we need to be very aware of is, do we need to do this? Do we need to make this drone? Do we need to do this intervention? Are we going to do more harm than good? And sometimes, when the only tool you have is a hammer, everything looks like a nail. And when the tool that you have is a drone, or when the tool that you have is, global sustainable production or lean manufacturing, maybe it just seems like it fits everywhere. But there are cultural considerations, there are economic considerations, there are geopolitical considerations. So yeah, I think there are maybe some of the most important decisions we can make is, where do we decide, where do we investigate, gather data, and at the end decide, okay, maybe now is not the time, or this is not the place for this tech. And let's use our resources and time for something else. Yeah, and that's something I would like to take up in the discussion later. Should we do this? If so, how? And if not, why not? Yeah, and I think David did a good job of mentioning this. Is this ethics washing? Is this greenwashing? One of the risks with technology when you then ship it to a different country is that you might have to worry about this idea of technological imperialism. So do we just build a drone in Denmark and ship it to Sierra Leone, and then it's not something that they can repair locally? It's not something that they've built themselves. So the idea is that our values, for example, Danish values or Chinese values or American values, have been built into this technology, and then when you try to transfer it to another country, that can sometimes be problematic. Yeah, something I'd like to discuss, especially David. I'm interested in this the collaboration with bestsellers. What do you do? Do you engage with people that have been criticized? Do you try to help them do better, or do you do you distance yourself from those people? For me in the drone industry, it's I would say the biggest elephant in the room is the military. Do I engage with them and try to understand what it is that they want to accomplish and help them make technology that leads to more just wars and more fair conflicts where less people are injured and killed? Or do I just shut them out and say, I don't do that. You do that, but I won't do that. And let's see, do I have anything else to say? Yeah. This is just something, a note about human values in the economy, because we will often be confronted with conflicts between these. I think David's talk was nice because he tried to show that sometimes you can have both. You can have economic benefit and and better human welfare, but this is not always the case, unfortunately. And then, just to remind people, the purpose of the economy is to serve the people and not the other way around. So I think lately sometimes we've got this a bit backwards, and the economy is driving us where it should be, human first. Yeah, that's all I have to share with you. I just wanted to thank you for having me, and thank all of my collaborators. I mean, I'm sort of making it sound like I'm just the guy who's sitting here, with developing all the drones myself, but that couldn't be further from the truth. I'm sort of the hands sometimes, but yeah, a lot of this has been developed with master students and colleagues from all the different faculties, from the humanists and social scientists, and of course the taxpayers paying my salary. So yeah, I'm very much indebted to them for their support. And this is academic, so of course I have to put a huge page of resources that I'm sure you all run off and read. Yeah, and that's all I have. Thank you very much for listening.
Thank you, Dylan. Thanks for thanking the Danish taxpayers who pay for a lot of this research. I've never seen that before, but it's actually quite appropriate, I guess.
Yeah, right.
What about the Queen?
Yes, and I would also
yeah.
Queen.
That's more sensitive, I think.
Okay, I have one question. I mean, you mentioned this about surveying for land rights in Sierra Leone. Do you see other applications for drones to help farmers in countries like Sierra Leone?
Yeah, I think the potentials are massive. The proposal that Morten mentioned is about managing water in South Africa, and this is something that drones could perhaps help a lot with. In Denmark, the potential for using drones in agriculture is quite significant. For surveying the fields and for doing precision agriculture. So instead of spraying the entire field with pesticides, if you need to use pesticides, you will have we have a project at the center called square meter farming. So basically, we're working at the level of 1 square meter to specifically dose that area. Does it need a bit more water? Does it need a bit more pesticide? So we can actively engage in very precise kind of farming rather than this old style where you just crop dust and and just spread all kinds of pesticides. So I think the potentials are very, very, very huge. But again, agriculture is a huge part of the economy in a lot of countries, and it's also people's food, livelihood, and their food. So when we go and start making changes in these processes, I think we just need to be very cognizant. One of my friends from the humanities, he likes to tell about this tomato harvester I think it was developed in the 1950s or 60s. I'm not positive about the time period. But anyway, a university in California, a bunch of researchers came up with this new kind of harvester that could pull the tomatoes down in a safe way. Of course, they're very fragile. And so the tomato pickers union sued the university because they said, hey, what are you guys doing? We're paying tax dollars, and what you've done is basically taken away all of our jobs because now we can't pick tomatoes. I don't think that they won that lawsuit, but I think it still is illustrative of some of the risks or problems that can happen, because we are making large changes in the agricultural. We would be making changes in the agricultural process. So yeah, lots of potential, and then also some risk as well.
I have two questions that might be related. The first one, it's quite intriguing and a very interesting example you shared, Dylan, about this design of the camera that only turns on later. So in that sense, you by design bring in privacy and other elements. But wouldn't it be quite easy to mod any drone or to put on an additional camera or anything if you wanted to, exploit or increase some of the functions?
Yeah, it would basically anything is possible with enough time and money and resources. When I go into the city, I still lock up my bicycle. It's not that somebody couldn't cut off the lock, but it would slow them down. And so the way that I look at a lot of these safety security issues is you might not always get to 100%, but you can definitely do something. And that will stop, like my dad used to say, it'll keep an honest man out. It'll slow them down, and it'll make sure there's not just people that are taking advantage of the opportunity. So one of the things we wanted to do with that camera system was we wanted to make that a black box. We wanted to make the camera, the transmitter, and the sensors that identified the altitude and that it was in fact flying. We wanted to black box that so that it wouldn't be easy to sort of take apart and disable certain functions. So I guess that was one way that we tried to approach it. But yeah, I guess in practice, you could potentially stick a small FPV camera on that has full range. But I guess it depends also on, are you most concerned about sort of like people that are actively trying to misuse the technology, or is it more like the sort of casual user? Say you're the drone operator and you got to fly from Adler to Svenborg every day, just sort of your routine thing. And then you're like, oh, well, I know somebody that lives on that route. Maybe I'll just, give them a quick buzz, or you happen to see something that you shouldn't have seen because you have this HD camera flying around at your disposal. So, I think it's also a matter of just, keeping honest people honest.
And the follow-up question, but I think what's very intriguing is, like you say, who do you engage with and why, right? Yeah. But because if you may keep the honest people out, but but if you capacity build, and let's just talk about military here, because wouldn't it be better to have somebody who can have a more nuanced discussion about ethics rather than asking any company that would produce anything they ask for?
Yeah, so far my approach has been better to be at the table than to not be at the table, and be part of the discussion. So last year we had the Danish drone conference at the airport, and so it was like the first day was for for everyone. So it was mostly industry people and then some military. And then the second day was all military people. Everybody was sitting with uniforms, and there was a few people from academia and a few people from industry. And the military was saying, like, we want this, this, and this. Can you deliver it to us? On the first day, I gave a talk that was basically similar to this. It was capability caution, like, how do we make drones that do the things that we want them to do in the context that we want them to do them, and not vice versa. And, I got a lot of blank stares, I would say, a lot of confused looks, but I did get some positive feedback as well. There were a couple of people that came to me afterwards and they said, okay, that makes complete sense. I hope it's better to be present than not. For example, one thing I heard from the military was, they're like, we want you in industry and academia to be supplying us with stuff, and we want it to be very flexible. And so what I would suggest to them is that they have stuff that's maybe not so flexible, but very optimized for what you need to do in a military context. So, for example, having a privacy-preserving camera system in a military surveillance drone would not make any sense whatsoever. I mean, a military recon drone is used to capture, to gather as much data as possible. And in that context, that makes sense. There's no consideration of privacy of the enemy when it comes to military operation. But if you are making a drone that's going to fly medical samples and it's going to be out in Denmark or out in the civil society, that's a very useful feature to have. So what I would argue is that these are two very different contexts, and the capabilities of the technology that we're making should suit those contexts. And that's a different approach than what I've seen in the past. I mean, of course, it's very much, there's economic incentive to make a drone that you use for map making and that you use for recon. And actually, I worked at a company that was then bought by another company, and my colleague's mapping drone, which we used to make 3D models of Hammershus on Bornholm, is now used also as a reconnaissance drone. So yeah, I mean, the flexibility of the technology is quite high, but I would argue part of the reason for that is because those were not designed specifically for those individual contexts. They were made sort of as a multi-tool.
Thanks for listening to Ddrn podcast. Read more about Global South research on our website ddrn.dk.